Two planes occupied the same piece of sky at 11,000 feet, and nobody saw it coming. July 1st, 2002. Near the small Swiss town of Überlingen, two commercial aircraft were descending toward their respective destinations. A Tupolev Tu-154 carrying 71 people, mostly Russian schoolchildren and their teachers, and a Boeing 757 operated by DHL, carrying cargo and a crew of two. Neither pilot knew the other existed in that darkening airspace. The Überlingen radar facility was understaffed that evening. One controller was handling multiple sectors simultaneously, a violation of protocol, but not uncommon in European airspace during the early 2000s. He was managing both planes, but he was also on the phone with another facility trying to sort out a handoff. For a critical moment, his attention was divided. The Tupolev's onboard collision avoidance system, known as TCAS, suddenly blared a warning. Something was closing in. The Russian pilots heard it clearly: descend immediately, but at that exact moment, the ground controller issued the opposite instruction. Climb, he said, climb now. This wasn't a miscommunication. This was a fundamental conflict between two safety systems designed to work together. TCAS is supposed to be the last line of defense, a technological guardian when all else fails. But it only works if pilots trust it, and pilots are trained to trust their controllers. The Russian captain made a choice. He trusted the machine. He pushed the yoke forward and descended. At that same moment, the DHL crew heard their own TCAS warning: climb, climb, climb. They pulled back on their controls and ascended. Two aircraft, responding to automated warnings, moving directly toward each other. At 11:35 p.m., at an altitude of 11,000 feet, they collided. The impact was catastrophic. The Tupolev's right wing struck the DHL Boeing's fuselage. Debris scattered across the night sky. The Russian aircraft became uncontrollable. It spiraled earthward, crashing near Überlingen. All 71 people on board died, including 52 children. The DHL aircraft, though severely damaged, remained partially airborne. Its crew fought for control. For several agonizing minutes, they managed to keep the plane flying, but the damage was too severe. They crashed near the village of Überlingen, killing both crew members. In total, 71 souls were lost. The investigation revealed something deeply uncomfortable. Both safety systems worked exactly as designed. TCAS performed flawlessly. The controller issued instructions based on the radar data available to him. The pilots followed procedure, yet 71 people died anyway. The system failed not because anyone made a dramatic error, but because the system itself had a hidden flaw. The core problem was coordination. TCAS and ground control weren't communicating with each other in real time. The controller couldn't see what TCAS was telling the pilots. The TCAS couldn't know what instructions the controller had just issued. They operated in parallel, sometimes at odds, with human judgment caught in the middle. What made this accident particularly tragic was that it wasn't inevitable. The two aircraft were on a collision course that could have been avoided if either the controller or the pilots had possessed complete information. But aviation, in the early 2000s, was a system of compartmentalized knowledge. Each component knew only its own piece. The Überlingen disaster exposed something aviation had been reluctant to acknowledge. Human operators and automated systems don't always play well together. We'd built machines to protect us, but we hadn't fully thought through what happens when those machines contradict the person holding the radio. In the years following, aviation authorities worldwide made significant changes. TCAS systems were upgraded to communicate directly with ground radar. Controllers received training on how to interpret TCAS advisories. Protocols were rewritten to eliminate conflicting instructions, but these changes came at a price: the lives of 71 people. The Russian families who lost children that night filed lawsuits that took years to resolve. The German authorities faced criticism for understaffing. The controller, despite following all procedures, carried the weight of the tragedy for the rest of his life. Guilt, it turned out, doesn't care about protocol. What's often forgotten in aviation accident analysis is that the people involved were doing their jobs correctly. They weren't reckless. They weren't negligent. They were trapped in a system with hidden vulnerabilities that only revealed themselves when the worst possible scenario occurred. Today, the Überlingen collision serves as a case study in every aviation safety course. It's taught not as an example of failure, but as evidence that even well-designed systems can have blind spots. The lesson isn't that we need better people or better machines. It's that we need better communication between them. Modern airspace is safer now because of what happened that night. Redundancy has been built in, information flows more freely, automation and human judgment are more tightly integrated, but safety improvements rarely come without cost. This one cost 71 lives. The families of those who died found no comfort in statistics or improvements. They found a child's empty bedroom, a school desk that would never be filled, a future that would never exist, and a reminder that behind every aviation safety rule, every protocol, every redundant system, there's often a tragedy that demanded it. The Überlingen collision remains one of aviation's most crucial lessons. Technology and human judgment must work in concert, not in isolation. When they operate separately, the sky isn't big enough for both of them. Subscribe for the untold stories behind aviation's deadliest moments, where investigation reveals what systems failed and what we learned too late.